Hello, do you guys see me? By my screen?
Yes.
Yeah.
I think I should have uploaded another one. I don't think I should have uploaded that one
Fine.
because
Hmm.
So are we uploading our problems or the problems you gave us?
No, you're uploading your problems because that's what I'm giving you your extra credit points on. So I'm going to look at what you guys gave me, and if they are reasonable and they make sense, then you get your points. If they're not reasonable and they don't make sense, then you don't get your points. You see how it works?
Yes.
And then I get to see if I get to use those on your exam.
oh,
So you guys get to say you made your own exam. You kind of sealed your fates, right?
Mhm.
who made the easiest one?
It doesn't mean I'm never giving you an easy question. You got to work for it. You're earning this A, right?
You work, yeah.
Right. Okay, so this is our problem.
Dr. Henry, our problems, is it
Uh-huh.
meant to be complicated or easy? Does it really matter?
It could be a wide range. You could have easy ones and you could have complicated ones. The key is that you want to make sure that you understand how to set up that problem. You saw the mistakes that I made. You don't want to make my mistakes, right? Because you
Okay.
guys want to be better than me.
Okay. Like how many problems?
I just need one problem, one really nice problem. And
Okay.
that problem should be where you have your stick structure in one case, and then you should have another one that is the name.
Okay.
Yeah, Judy, you want to hide your answer, right?
Oh shit, my bad. Okay, you know what? Let me give you guys another one. You guys already saw it. God damn it.
This is how I studied, right? So what I would do, I'd get together with a couple of my friends. We all do our own little problems, and then they're like, okay, name this one, right? And most of the time, they never really exist because they're really hard to make those. But just the point that you can name just about anything, right? And it pushes you to that limit, right? And by you guys, you're helping each other, you're pushing each other, and you're like, no, 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 this is how you would do it, and you'd argue about it and stuff like that. But that's how you get the concepts. The
Yeah.
best way of learning is teaching, right? Because it requires you to learn enough that you can teach somebody else, right?
Yes.
And don't you feel like, are you guys starting to work in groups, right?
Yeah.
Yeah. Don't you feel like after you sit there, you start getting a grasp and you explain it to somebody, you're like, God damn, that's all it was. And you're like, man, I was really making that hard. And then you teach somebody else, and then, you know,
Yes, the epiphany when you
Mhm.
find it. Yeah. Um. Okay. You know what? Since you guys saw that one, can I just draw one real quick?
Yeah, go
Ah,
ahead.
okay. Let me go
I'll
to
be
my.
quick. Come on.
Yeah. Okay. Hold on.
While
God.
you guys are doing that, I'm
Pressure.
going to make a quick run somewhere. I'll be right back.
You can
You guys
pressure.
talk to each other.
New share whiteboard. Okay. Okay. Maybe I shouldn't add a halogen one if you guys aren't comfortable with that. How do you guys feel about the halogen one?
Good, as long as it's not like a bunch of them.
Okay. So let's do this. Let's go. Let's go that one, and then that one, that one. Oh shit. Asshole. Oh god. Mm. This will be easy. Let's go. Mm. How do I? Oh, here. That's a pretty easy one. You guys want to try it?
Yeah.
Sure.
How do I go back to annotating?
Under the options.
Options? There's options.
On mine, it's on the top, in the middle, kind of.
In the middle.
It says view options.
Oops. Oops. Hold on. My bad. Oh, here we go. It came back up. Okay. Gracias. Okay, somebody else draw another one then.
Man. Methyl. And one, two. Mm.
Is that it? Oh, never mind. Was that it for this one?
Yeah.
Yeah, okay, okay. Got it. Did you make an M for your name, Matt?
Yeah, guilty.
Oh, very cute, very cute.
Oh, yeah. Oh, it's supposed to be all online though, unless he's doing like. Oh, yeah.
Was that it for the green?
Yeah, if anybody else wants to do a trickier one, that's fine. I just thought I'd do some practical ones for those who are still.
Okay, let's go tricky.
Okay.
Let's get tricky. Trick. Okay. Let's see.
I can draw out a tricky one if you guys want.
Yeah, do it.
Yeah.
Oh, what did I do? Oh, there we go. What am I doing? Holy crap! What is that, Tiki Man?
I don't know. It looks like a Mayan symbol or something.
I,
'Cause,
'cause- 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 Selena, was that it?
That's it.
Okay.
Do you guys want to talk about maybe one of these easy ones before he comes back?
Yeah.
Yeah,
You
we
want-
should do that.
Okay.
You want to do Judy's first one or my little M bro?
Oh, what did I do? Undo. M bro, let's go M bro, bro.
So this one, you want to start out with counting how many carbon chains you have, and you want to start where you have your highest priority. So in this case, it would be from right to left. So you have bromine right here. So we would start with 1 right here. 2, 3, 4. So if it has 4 carbon chains, then that would tell us that we have a butane on the end, because bu equals 4. And then we're going to say butene because it has a double bond.
The butane, do you identify where the double bond is? Do you have to put a 1 in front of the butene, or is it just kind of...
Perhaps, yeah. So if you guys have some feedback, definitely let me know.
Oh, I'm just curious. I'm not too sure.
Okay.
But
Well, I'll keep going, and then when it's finished, you guys let me know what you guys think.
Okay.
And we've got 1 bromine here. So that would be 1 bromo butene. Is that right?
What I think, because this is what how I figured it out. I counted the carbon chains like you counted, and I started on the right because that's where our double bond is at. I did get butene for our highest priority, and then for our next higher priority, I got the 1. Actually, it would be the 1, right? Because see, that's what I'm kind of confused, because if you count the carbon chains, like 1, 2, 3, 4, I would assume that it would be like bromo dash 1 dash butene.
Because it only has 1
that-
bond.
Yeah.
Yeah.
Or maybe it's like 1 bromo dash.
Is it like dash N or?
Oh, you know what? Maybe.
But doesn't the ENE identify that there's a double bond there already?
Yeah,
Or
but
do we have to identify where... See, that's where I'm like, do we put the 1 in front of butene to identify that that's where the double bond begins?
I think you are supposed to.
yeah. So it should be 1 bromo dash 1 dash butene.
Or it could be 1-en-bromo-butene.
Okay, let's write those answers down, and then Dr. Henry could let us know which one's correct.
Okay. Who was that last person talking? It sounded like they were pretty confident.
Just.
Oh, Lupe.
I don't know. That's how I've been writing it down, where I have the bonds. I
Well,
put
what
the
did you get?
EN.
I'm sorry, start from the beginning. What did you get?
Let me write it down.
Okay.
Okay, so see, I oh, let's see, this work I put it down here. The what that combines it? D is a die, right? Two is two, and N what's EN mean? Do you know?
Jessica, what were you saying that you thought the EN stood for?
The EN stands, from my knowledge, it stands for the double bond.
Oh.
To identify where the double bond is, but that's where I'm confused because we're identifying it twice in butene and then one EN. So I don't know. I don't know which way.
Yeah, I think
is the right way.
Right. I think she's right about that. I think when you only have one double bond, you would just put the one in front of the butene.
Right.
But if you had multiple, we'd probably put another number and then the dash EN.
Right.
So I believe the only time we're actually using EN is when we use like alkyne. When we have an alkyne.
Oh, but
Mine would be
wouldn't it
YN.
be an ENE if there's a double?
So we would put like 5 EN and then dash like 3. So if there were like different numbers of alkynes, we would put like 3 and then a comma and then 5 and like whatever, and then we would put whatever YNE.
Okay.
Oh, when it's a YNE, yeah.
Yeah, so that's the only time we're actually using EN.
Okay.
So
Okay.
bromo dash 1 dash butene.
Let's see. Okay, so here's my question. Is that possible?
No,
Why not?
because there's more than 10.
We're talking about this one, right?
Which one?
The first one?
We're working on the second one.
You're working on the second one?
Yeah.
Okay. So this is the second one?
Yeah.
Okay, but let's talk about that first one.
Okay.
So first off, we have bromine, right? So because bromine, the way bromine works is it's only going to have a single bond. It will never have a double bond. I should say it's rarely ever has a double bond. I shouldn't say never, but typically never.
Would it be for all the halogens or just the
Yes.
bromine?
All of the halogens, right? They only want to have single bonds. They're very selfish. They don't like to share more than that one electron that they have available, okay? So you guys want to keep that in mind always, okay? This is a very unstable type of situation. That won't happen, okay? But if it were to happen, right, because this would also not be correct because you have a double bond between the bromine and the carbon. So you would actually name that different. So you would want to have, can I make an adjustment real quick?
Yeah.
Let's see. If I can find my annotate. Maybe. I'm trying to make an adjustment. Hold on. Oh, there we go. Sorry, it took me a while. And right now, that would be your, so this is your first carbon. This is your second carbon. Oops, this will be your third carbon. This is your fourth carbon. And then that would be your fifth carbon. So then you would change the name in that case. So then it would be 1 bromo, 1, instead of butene, it would be pentene.
Mm.
And thank you guys for going ahead and working without me. That makes me feel good. I really mean that, because that means that you guys are willing to learn. You want to learn. You're not just waiting. Okay.
So
Yep.
oh, I know that I automatically knew that it was butene, but you know how like you have I know it's one bromo because obviously because of the double bond, but the -1, how did you get that?
That tells you where the double bond is located at.
Oh, okay.
This also tells you where the bromo is located at.
Okay.
Right. So it's important for us to give location to where things are at. Otherwise, we don't draw it correctly.
Okay.
You know?
So the one has to be in front of the bromo?
Yep. It should be, this would be one pentene, and then you have one bromo,
Okay.
right? Because they're both being attached to that first carbon.
Okay.
Sorry. I'm really screwing up your guys' study session here. Okay?
Some of us were a little confused. Can you clarify when to use the EN? Is that only when we're working with like the Y and E?
Mommy, I got open Papa coffee.
No, they're not. They have chemicals in them as well. So, sorry. So the way that you always use the ENE always stands for double bonds, right? Double bonds that are carbon, right? Between carbons. Okay. You don't use double bonds between other things, ENE. It only means the hydrocarbons. Okay. So that means only with carbon and carbon double bonds. Okay. Y&E only use triple bonds between carbons. And A&E is only going to be used when you have single bonds between carbons. Okay, so let's look at the second one, right? So how many carbons do we have on the second one?
Which one's the second one?
This is going to be my second one in my mind.
Okay.
Oh, okay.
That's the one I drew, so I'll try to explain that one. What I did was count my longest chain. So I started, how do I annotate? I don't know how to do this anymore. Stop. Oops, my bad. Hold on. I got this. Okay, what I did was I counted my carbons to see which longest chain I have, but I don't have bonds of any sort, so.
You mean you don't have any? There's plenty of bonds there, I see.
I mean, double or triple bonds.
Okay.
To make me start on the other side.
Okay.
Yeah, that's what I meant. Because if I had like a triple or a double bond like here, I'd count backwards. To have a shorter, at least count.
Okay. But even in the context when you have your single bonds, when they're all single bonds, you also, if they have appendages to it, then you want to sit there and find the shortest way to that appendage, anything that or that attachment.
Got it.
Right?
So,
So we say that Cl is an appendage, right? It's an attachment.
Is that the same thing as a substituents, appendages, substituents?
Substituents?
Yeah.
Yes.
Yeah, okay.
Or we'll call it functional group.
Functional group, okay.
Yeah, that's what we call it in chemistry.
Okay.
Yeah.
So then if I wrote it this way too, I could see that I don't have, my red numbers don't really, well, let's see, 1, 2, 3. That would be 1, 2, 3, 4. So I would still stick with my black numbers.
Okay, black numbers it is. Good
And
job.
then what I did was, so my longest chain has 8 carbons. 8 carbons is a oct, and it's only single bond, so it belongs in the alkene. So it's going to be octane.
Okay.
Whoop. Octane. If I could spell that. Octane. So then what I would do next is look at where my functional groups are at, because I don't have to look for any triple or double bonds. And since I'm looking at my black numbers here, I know that it's the functional groups are coming off the 3 and the 5. So I would continue to write it as so 3, 5. And because there are 2 chlorines, I would put the prefix in front of the chlorine. And since it's a halogen, it doesn't have the white L's behind it. It would have an O. So it would be chloro. So I would go dash, and it's 2 of them. So the Greek numerical number, or however it's called, is di. And then you just add what I said about halogens, ending in O, chloro. And I hope I did it right, but that's my brain.
Well, your brain is on right, so it's correct. That is correct. So it's 3,5-dichlorooctane. Okay. So I'm sure that those who are in the evening sections that are here in the morning sections, so you guys are starting. You should recognize now we've introduced you to another functional group. That functional group are the halogens. The halogens are the lowest on the totem pole. Okay. So although we take them into consideration as functional groups and finding the location where they're at, they still are the lowest one. So they're the low of the low. Okay. So far your order should be, if you guys are keeping track of all your functional groups, Judy, do you mind if I write on your, whose ever screen is this?
Go for it.
Thank you. Thank you. So we found a nice color. You guys are using all the good colors today.
I try. Kind of like that.
You guys are not whining already, are you? I don't hear anyone. That's not whining, I hear, right?
Dr. Henry, I just need to say this out loud. On this last one, this 1-bromo, 1-butene, we're saying that we have 1 bromo, and then we're saying the second one is where the bond starts.
Yes, the second one
Okay.
here. So in this case, because I adjusted it so that it would be correct.
Right.
Yeah,
Okay.
you're saying where that bond starts. It starts at that first carbon. So it's between the first and the second carbon. You always put the number is where that bond would actually start at. So if it's that triple bond or if it's a double bond, that is the number that you have. You have to tell me where it's located, because if you just said 1 pentene, right? Let's say we just erase this just for kicks and giggles. Find my eraser. Oh, I don't have control of the screen. So since I don't have control of the screen, we're going to put an X there.
Sorry.
No, it's not your fault. I'm going to put an X there. So let's say we didn't have that there, right? So in that case, I could have the double bond. It could be here, it could be here, it could be here, or it could be there, right? It could be anywhere on that molecule, right? So we wouldn't know where it's at. So then we wouldn't know how that molecule is going to behave, because if it's here, it's going to behave differently than if it's here. If it's here, it's going to behave differently than it was if it's here, right? Because of the surrounding ones that it's connecting. There's a bromo at the end here. It's going to behave differently. than it would behave if it was over here, which just has carbons. And then this is an N carbon, where this is a middle carbon, so it's going to behave differently there. So depending on who you react it with, you're going to get different products from it. Do you guys understand that?
Dr. Henry?
Yep.
I have a question about the 6-methanol, 3-ethanol, or yeah, octane. Anyways, the one in the corner. So you know how I see where you got the 6 and then the 3, but my thing is like, isn't 5 also considered methanol or no?
Yeah.
So let's actually talk about this, because this isn't mine, but we'll talk about it. I think they made a mistake. That should be 5-methyl, right?
5, yeah.
Yes.
I'm right?
Yes, you are
Oh
right.
my God,
And
yay.
you spell methyl with an E, like a meth head. Meth, oh, right? So this one would be 5. Oh, actually, no. Let's correct it, right? So where will we start counting from?
The left.
I thought it was from the triple bond.
We would start from the triple bond. So let's fix this one completely. Nice try, but not quite there. So that's 1. This is 2. This is 3. This is 4. You guys draw such good figures, though. I'm jealous. 5, 6, 7, and 8. Right? So we would start from the left and go to the right instead of going from the right to the left, because the triple bond is in that first carbon position, right?
Okay.
That would be a lower number. Is that correct?
That is the lowest number.
Okay. So then we would name this guy so it would be 4 methyl. Okay, you guys are gonna help me, or am I just gonna sit here and look cute?
Before methyl, 6-ethyl.
Mm-hmm. Then
YNE.
Wouldn't you put 1 octane?
There we go. We have to tell me, you gotta tell me where the triple bond is at, because the triple bond could be anywhere. If you, on this one, it could be in the middle, it could be in
Right.
New York, it could be, okay, so you gotta give me the location. So it's 1
octane.
octane.
Well, okay. Okay.
Okay, so you got to remember to give the location. Okay, that's important.
1, 2, 3, 4. 4 metal.
You guys understand that, right? So I could have had it here. It could have been here. It could have been here. It could have been there. It could have been, I have so many different places I could have stuck it, right?
Ah, crap. Hold on.
And that's for this guy right here.
How did I,
Hey, what about this guy here? Oops. I cut it off.
American Ambulance, this is Judy. Okay, we'll be there. Hey, I gotta go, guys. I'll try to log on my phone.
It's
Okay.
Judy,
I'm gonna stop sharing the screen. So if somebody
Okay, so
wants to save it.
Let me save it real quick. Hold on. Okay.
All right, I'll see you guys in a bit.
Okay. Bye-bye.
Bye.
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 So let me start sharing my screen. thought she said she was going to log out. Okay. Can you see my blue screen? Blue screen of death?
No. Yes.
Yeah.
Yes.
Yeah. No.
There you are.
Okay. You see it now?
Yeah.
Okay, good. Okay, so I cut off the methyl there, but sorry about that. Okay, so what are we going to do for this guy here that we have the box right there for?
You're gonna count your longest chain.
Okay, I'm going to count my longest chain.
So
So,
start from left to right.
From
Okay.
left to right. So
1,
2,
2,
2,
3,
3,
4,
4, 5, 6, 7, and 8. You guys are
Okay,
liking
and then-
8, I see.
and since you don't have a double or triple bond, you can start from left to right.
Okay. So I can start from left to right. Okay.
Yes. So
And then also look at our functional groups. We have one at 3
yes,
and we have 1. So you also want to pay attention to that too. Okay.
right.
So what am I going to start with then?
3.
Did you
3?
Your methyl. No, you're methyl. So you're 4.
4. 4 methyl.
Yes. And then
Then
3
3
ethyl.
ethyl.
3 ethyl.
Yes. And then it'd be, since you, I don't know if you would have to put, I know it'd be octane,
Yeah.
but usually when you're starting with like a double or triple bond, you would include the 1. So would you still put 1 octane since that's where it's starting? Or you would just leave it as octane?
No, you leave it as octane. Is there a difference between this single bond and that single bond and that single bond and that
No.
single bond?
No.
There's no difference, right? So in the case of the double bond, that's a double bond, right? It's different than a single bond. Do you guys understand?
Yes.
Yes, no, maybe?
Yes.
Yes.
Yeah.
Okay. Okay, so simple piece of cake.
Dr. Henry, I have a question.
Mhm.
For the numbers, is it supposed to be in ascending or descending order?
No, the numbers, so you always want to start, let's say you have dimethyl, you always want to go with the lower number and then say, okay, that one's at 1 and that one's at 2, right? And then dimethyl, whatever it is. But what it matters here is what's located, what is it attached to, right? This is a methyl. You always want to start from the one that has the lowest priority.
Okay.
And then it goes to the next highest priority, and then it goes to the next highest priority. So if we had 3 things, let's say we had a methyl, methyl, and propyl, then it would go methyl, ethyl, and propyl, right? Because it's based on size. Priority would be based on size. Okay. Good question, though. Any other questions? You guys getting the hang of this?
Kinda.
Kind of.
Yeah. Can we do another one?
Yeah, let's do this last one that you guys have drawn. It's
That
crazy.
was so weird. I don't know how to do that.
Oh, I don't want to hear. I don't know how to do that. What's the first thing that you always do, right? I like it. I think it's crazy.
Okay. I don't even know where to start.
So
Start at an end, right?
is any of this on like the rules and stuff, you know, the prefixes and then like the definitions and stuff? Do you have that under resources or anything?
Nope. It's all in your chapter, your notebook. It's actually in the chapter itself. So if you go to chapters, this is chapter 21, and there's also chapter 13. Yep. But don't worry, you're going to be building your resources, right?
Yeah, I have some written down. I just want to make sure that I have them correct.
Okay.
But yeah, I'll double check.
Dr. Henry, before we move
Don't
forward,
worry, I will have something by the end of the week for you guys. So, because
before
I'm
we
going to give you the priority list. Excuse me? Go ahead. I'm sorry, I cut you off twice.
no, it's okay. It's my fault. So let's go. Can we go back to bromine? Because I have a question. So
Okay.
for bromine, we start from the bottom to the and then the top, or is it from top to bottom for this?
Do me a favor. You have to draw and circle what you're talking about.
Okay.
So I don't understand what you're asking me.
Because I'm a little confused. Because you know how? Because I honestly I put one up here, and then there's one here, and then two here.
Yeah, because it's carbons. Are we counting the bromines or are we counting the carbons?
Oh, okay.
So you guys got to remember, you're counting carbons.
Okay.
You're not counting everything. This here, this N here, this is attached to bromine. That's bromine's spot. This is a carbon.
Yeah.
Okay.
Mm-hmm.
So does that clarify it? You understand it now?
Yeah.
Okay. So we're counting carbons. Okay. So let's start counting. Give me an N to start with. Where do you guys want to start at? Somebody star an N.
Put it inside the spiral.
Start with the one inside the spiral. We'll make that one.
Mm-hmm.
Okay. Now, I will say structurally, this will never exist, right? It won't look like this in terms of its structure because there are too many forces that will be playing on it. But I just want to do it because I think it's crazy. So that's one. This is two. This is three. This is four. This is five. This is six. This is seven. This is eight. This is nine. This is 10. And this is 11. Is that the longest chain?
Yes.
That is the longest chain. So you guys don't know about 11. Yeah, it is. All right. So
Methyl.
I got carried away with the names. They want to sit there and make me pull out the hard stuff now.
Did I number it? Have it started on the wrong side? Like should it be towards the opposite way, like where the 11 is?
Let's see. That would be our first. So if we do 11, that would be 1, 2, 3 before we get to our first thing. Let's see. But that is a methyl group, right? Mm-hmm. If you started from the beginning, that's 1, 2, 3, 4, 5, 6 before we get to that's a propyl, right? So let's see. Before we get to a propyl, 1, 2, 3, 4, 5. So yeah, you did start it at the wrong spot. Okay. So we'll flip it. Right. So let me show people what we're talking about because I'm pretty sure that, I mean, although you guys are sharp, it's a little tricky, right? So if we start this way at 1, this will be 2, 3, 4, 5, 6. That one on the inside there is 7. This is 8. This is 9. This is 10. And this is 11. So if we go here, 1, 2, 3, 4, 5. At the 5 carbon, there's 1, 2, 3. So that would be our closest compared to, this is at the 6 carbon. 1, 2, 3. You guys see that?
Mm-hmm.
So we'd want to start from this because it makes our the longest appendage, which is going to have priority over the lone appendage here.
Oh my God, it's just everywhere. I don't know what to do with it. Okay.
Okay?
So are we following the blue or the red?
The red.
You're following the red. The red would be the correct way.
Okay.
Okay?
So how to do it?
Okay, you guys ready for naming? Since there's 11, and remember we only stopped at 10. So with hydrocarbons, what you're going to do is, since it's 11, you're going to say meaning one, decane. So 1 added to 10 is 11. So that's going to be the base. So that's going to be at the very end. Okay? So
How about 12?
where's my methyl groups at?
Size 10K.
Where's what?
Methyl groups.
4.
4.
Oh, that's not methyl, that's ethyl.
We don't have a methyl to start off with?
3?
No.
So let's see, 1, 2, 3. Add 3. That's our third carbon right there. You want me to erase the blue so you guys can see it? Oops. Oops. And do you guys mind if I make it a little bit bigger? If I can?
Sure.
Which is going to change my numbering.
Oh.
Is that better? I just got to fix all my numbers. Oops. So 1, 2, 3, 4. Five, 6, 7, 8, 9, 10, 11. Okay, so my longest chain is called a dodecane. Okay, so we are also saying is there a methyl group somewhere at 3? What's at 3?
Wouldn't that be ethyl?
That's just a single line.
Oh,
Methyl?
So that's a 2 right here. This is a 2. This refers to the, oops, So 1, 2, 3. You see that line right there? Isn't that a methyl?
Yes.
Okay, so there's one methyl. Okay. So where's the methyl located at?
3 and 4. No,
Okay, where are my ethyls?
at those 2.
So this is 1, 2. So let's circle our methyl in green so we can see that clearly it's a methyl. Okay, so is this a methyl or not?
Yes.
Okay, where's our ethyls? We're going to circle those in blue.
Okay. So our ethyls are right in the 4
Okay,
and then 5.
is that an ethyl or is that something else? How many points?
Oh, no.
That's 1,
That's
2,
not.
3.
It'd be 3 and 4.
So
It'll just be that one, no?
it'll just be that one because this is 1, 2.
Oh, it's part
Right.
of the main chain. Never
It's
mind.
part of the main chain, yes. Yes, that's why we number our main chain. So if it has numbers, it's not counting towards that, okay? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's our main chain, okay? So this 7 refers to this corner right here. This 6 refers to this corner right here. This 5, this 4 is that corner, okay? So what is this? That's 1, 2, 3. 3 carbons,
Propyl?
propyl.
And there's 2.
So
And there's 2 of them. Excellent. So we're going to do the propyl in pink. Oops. Propyl. And propyl. Okay, so then it would be, oops.
Propyl?
So what is it? 4 ethyl. 4 ethyl. And then you said what propyl?
5, 6.
5, 6.
5, 6.
Propyl?
Dipropyl.
Dipropyl. Okay, piece of cake.
Let me try to
I don't know how much time we have, Dr. Henry, but one would be nice if we could do one with a bunch of elements attached to it.
Okay, don't worry, you're gonna do stuff with a whole bunch of stuff attached to it, but I need to get you used to all of the major players.
Okay.
Okay, so we've kind of have to move forward. We need to get to the major players. Okay.
Dr. Henry,
Mm-hmm.
I have a question, please. You see,
Okay.
the numbering, most times I get confused on the numbering of the carbons.
Uh-huh.
Like if you see, check the diagram right now.
Yeah.
You see the constituents 1, 2, 3.
Yep.
So to me, I thought maybe this is just like a constituent, like one of these ones. Do you understand what I'm saying?
So you're thinking that it was a functional group.
Exactly, like this. So if you leave me, I would just say 3, like 4, 3. I'll start if I want to start my numbering from here to be 1, then 2, like that.
Yeah, okay, so the rule is the first thing that you always want to remember, you want to find the longest carbon chain, right? The reason why you find the longest carbon chain, if you don't find the longest carbon chain, you get really crazy structures, right?
Okay.
So you want to make sure you encompass the longest carbon chain. So that's going to be your base chain. So you want to go through and find the longest carbon chain. So that's where you start your 1. You always start at an end, right? If you can't start in the middle, you always have to start at an end.
Okay.
So that's 1, that's 2, that's 3. If I started from here where this green started, that'll be 1, that's 2.
Yeah.
So that already by looking at it in this appendage here, that's already bigger than this one. So I know immediately I need to look to this one because it has more carbons attached. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? That encompasses everything. Had I started here, it wouldn't give me enough. If I start over here, this guy has 1, 2, 3, 4, 5 carbons, right? So then this guy only has 3. I know 3 plus 5 is only going to be 8. So that isn't going to work.
Yeah.
And so you want to sit there and look at it. What is going to give me the longest carbon chain possible?
Okay.
Always, that's the very first step.
Okay.
And you know, that carbon chain, those carbons can only be used for that long carbon chain. They can't be used for anything else.
Right.
And they're going to be what you're going to use to number everything else. So you always want to make sure you have the longest carbon chain so that you can find the location of everything else.
Okay.
Then the next thing that I do, right, it's just me. I can't see things naturally, so that's why I have to circle things in different colors. Okay, my methyls are going to be green. My ethyls are going to be blue. And so that you see that I circle those so that I can recognize, okay, that's 1, 2, 3 carbons there. That's 1, 2, 3 carbons that's attached to that main chain. This one has 2, 1, 2. So I can see the difference between them,
Okay.
right?
Yeah.
And so then that helps me set up my organization. So then it's real easy. Okay, so if all my methyls are going to be in green, so then I just look at the ones, how many methyls I have. I have 1, and it's at 3. Okay, so 3 methyl. Then I have 1 ethyl, right? And it's at 4. So that's 4 ethyl. And I know I have 2 propyls. Oh, 2 propyls, right? So then that's 5, 6 dipropyl. Okay, so by taking the time, finding the longest carbon chains, taking the time and use colored pencils. You guys, colored pencils are cheap. You can get them at the dollar store for about $1, right? You can find $1 in your glove compartment or in your seats at home or your dad's pants or husband's pants, right? Or wife's pants for those who have wives. So.
Thank you.
Yeah.
Dr. Henry.
Yep.
So are we gonna need to know more than 11, like that on decade?
You know, I just put you guys up to 10 at this level. You're just going to do 10, but this was just I just wanted to do this case. Right? So typically 10. You guys drew this one, so it wasn't my drawing. Right?
Okay.
You guys challenge each other more than I challenge you. So. Okay.
Dr. Henry.
Yes.
Just one quick question. You know, like on the middle here, the one for metal, 3 ethyl and octane. You know, they count from 1, 2, 3, right? 4, 5, and the 5 over there, they have another line going down. It's just, do I have to put like metal too? Like 3, 1, 2, 3, 4.
Which one are you talking about? Which one you saying? The one here?
Yeah, no, this one. The one for metal, 3 ethyl.
Methyl?
Octane. Yeah.
Methyl 3 ethyl? This one right here?
Yeah.
This one that I'm moving right now. Yeah. Because you got to remember, I can't see where you're pointing to. Okay. So this guy. So this guy right here? Is that what you're making reference to?
Yeah.
Okay. Oh, yeah. So my numbers have moved. So let's see if we can move them in the right spot and so that they'll be.
Oh, okay.
Yeah.
No, sorry.
So because I blew it up,
okay.
My numbers moved.
Yeah.
And usually, well, in real life, the bond lengths are going to be the same. But since we're drawing this by hand, we don't have a nice little program to do it for us. The bond lengths are going to be crazy. Okay, so does that answer your question, Andy?
Yeah.
Yeah. Okay, any other questions? So that's $275 for that bit of time right there. I accept debit and credit. One day I'm going to convince you guys to pay me. One day. Okay, let's see what we can do. Okay, let's see, share screen. That's what I want to do. I want to close this guy. Don't worry, it's going to get more exciting, and then you're going to be like, oh, this is the best stuff ever. Aren't you guys already feeling that?
Yeah.
Good.
Feeling overwhelmed.
You're not overwhelmed. You can handle it. Okay, so this is basically showing us that there's a couple of things that we're getting at here. And we're not going to talk about so much the isomers because there exist isomers to everything that we've talked about, right? And one of these isomers, so we have the N-butane. That's basically, N is an old school way of saying it's all in a straight line, right? We could also have what we call isobutane. So before we got to that whole concept of nomenclature, we would use the term iso. This is one of the old school terms. We go by IUPAC. IUPAC basically gives us the way that I've been teaching you. That's the way that's new school, right? Old school, people like me, we call stuff isobutane because it had 4 carbons, and then there's 1, 2, 3. On this middle one, we have a single methyl group, right? And so we would call that isobutene in the old days. What would you call this now? With IUPAC?
Would it be tetrahedral?
No, I'm not asking you the shape. I'm talking about the name.
Oh.
So old school, we call it isobutane. What do you call it now? Using IUPAC nomenclature. Name this guy. This is what it looks like. There's 1, 2, 3 carbons. Where am I going to start numbering from? What is my main chain? What is the biggest chain I can get?
It's the top one.
Isn't it just 3?
It's just 3, right? 1, 2, 3. Now, again, think about what I'm asking you, right? You guys are getting caught up. You're not thinking about the question. The question is, name it. All you got to do is name it. How would you start naming it? You count the carbons. 1, 2, 3. That's your longest chain, is it not?
Mhm.
Bro, is it not?
Yeah.
Okay, so 3 is the longest chain, is it not?
Yeah.
Okay, so we have 1, 2, 3. So what would we call that guy?
Purple. Or
Okay. So would we call it propyl, or would we call it, because it's the main chain,
We'll call it propane.
propane?
Okay.
Okay. And then
Okay.
what's hanging off of that propane?
Would do 2-methyl.
No, that's an ethyl, right?
That's 1. These are all hydrogens.
Oh, okay.
1 carbon. The black is the carbon.
Okay. Oh yeah, so it is methyl.
So 2-methyl propane. So this nomenclature is called IUPAC nomenclature. What you're being taught, what I'm teaching you, is IUPAC nomenclature. Old school nomenclature, if you look it up online, if you write 2-methyl propane, you'll also see isobutane. This is old school nomenclature. So people my age, we use isobutane. People your age are using IUPAC nomenclature because there's a committee that says, you know, the way that we named things before was kind of crazy, right? And so they try to get a very systematic way because otherwise we were getting names that didn't make a lot of sense. And there would be 2 things named exactly the same thing, but they would be 2 totally different structures. You guys understand?
Mhm.
Okay, so depending on who you're talking to, you're going to use IUPAC if you're talking about somebody old like me, you may want to use the classic way, right? This is classic. Classic means what to you guys?
Old school.
Old school, right? So when you listen to classic, you guys call classic 80s now, right?
Yeah.
And 90s. Oh, that's classic, right? Okay. So when you guys talk about like classic rock, you guys are talking about stuff that was, when I was a kid, that was the shit, right? And now your concept of classic rock or classic this or classic rap or, you know, that's like my generation, right? Okay. So these guys are considered to be isomers of each other because how many carbons does both of these guys have?
4.
4. So both sets, the isobutane and the N-butane, have 4, but they have different structures. You guys see that?
Mm-hmm.
Piece of cake, right?
Yes.
Okay. So these are isomers of each other. This one is N-pentane. This one is what we call isopentane, because I'm old and that's what I would call it. And this one we would call neopentane. Now, I want you to name these using IUPAC methods. Give me the names of the iso, give me the names of the neo. Do I have to pick somebody to do it? Who am I going to pick on?
Wouldn't it be 2-methyl and then butane?
So you said 2-methyl for this one here.
Yes, for the first one.
2-methyl butane. Okay, longest chain, 1, 2, 3, 4. We know that that's but. So butane. And then we have a methyl coming off the second carbon. 1, 2, 3, 4. Right? So make sense? Good job.
How do we know that's a methyl? What does an ethyl look like in that kind of structure?
You'd have a big black ball. Let me see. Oh, let me find it. Hold on. Give me 1 second. Actually, let me fix this real quick. Hold on. Let's see. So the white balls are the hydrogens.
Mm-hmm.
The black ball is the carbon.
So kind of the same, just another branch.
Yes. It's 2 carbons, right? Instead of just 1, you'll have 2.
Okay.
But you wouldn't really have in that case because that would be your longer chain, right?
Mm-hmm.
So then it actually would change the name. So you wouldn't have 2-ethyl because where it's located at.
Right. Okay.
So, but anytime that all it is the addition of a carbon, right? So you have a longer carbon chain. So ethyl is bigger than methyl, right? Methyl is only 1 carbon. Ethyl is 2 carbons. Propyl is 3 carbons. What is 4 carbons?
Butane.
Bu. Yep. So a butyl. So it'd be butyl if it's a side chain, right? So you guys get it. If it's a side chain, you put YL at the end of it for the carbon chain. Okay. So what is this guy?
It's,
Longest chain is what?
3.
3.
Longest chain is 3. So then what is 3?
Propane.
Okay.
Yeah.
Okay, so what should go in front of our propane?
Ice, water.
2 dimethyl.
So it'd be what?
Dimethyl.
Dimethyl. Where's the methyls are located at? Although it really shouldn't matter. 2. So it's 2.
Oh, it's got
Dimethyl.
Oh.
Propane. So it's same as a stick structure. Only thing now you actually see the balls of carbon. Black, carbon, whites, hydrogens. Okay, you guys ready for the next one? More? You say more, right? Okay. Oops. Okay, so we've talked about the carbons. We've told you that in most cases, when they're all single bonds, your shape is going to be tetrahedral. Each of the angles are going to be 109.5. We know that if it's 3 attachments, right, it's going to be trigonal planar. We know that if there's 2 attachments, it's going to be linear. And then also, in this case, in the case of double bond on both sides. In the case of a triple bond, it's always going to be linear. Okay. So the fact that I draw it with the kink is actually wrong. To be linear, but the kink is easier to see. So that's why I was drawing it that way. Okay. So you know how many attachments you can have with the hydrogen, and you also know that the halogens are just kind of like the hydrogens. They only want to have a single attachment. They don't want to sit there and share more than 1 electron, okay? We know that oxygen has 2 possibilities, especially when we're dealing with organic chemistry. It could be a bent structure, right? It can also be double bonded. Nitrogen is going to be trigonal pyramidal, or it's going to be an angular structure. Or if it's at the very end by itself, it can also be linear. Okay, so those are your 3 possibilities. You guys see that?
Mm-hmm.
Yes.
Okay. Okay. So this is also showing you that you could have the possibility of having structures that are identical to each other, right? These guys are identical to each other, right? But they're all on the same one, right? The only thing that's different is, I should say, they're technically, chemically, they're identical to each other. And this is why it's important for us to be able to name it. Where are the carbons located? I mean, where are the chlorines and the bromine located at? Which carbons?
The
second and third carbon?
So would it be the second and third carbon or the first?
Second.
First and second. We start here, 1, 2, 3. So it'll be the first and second carbon. Here, still first and second carbon. Here, they're both located at the second carbon. Okay, are these structures the same?
Yes.
mm-hmm.
Are they? Are all 3 structures the same?
Yes.
No.
Why aren't they the same?
Different when there's different bonds?
So, but you just told me that they were the same.
Right. So I think that they're the same because they all have single bonds. But if the bonds were different, wouldn't it change the structure?
Okay, so structurally, are these the same?
I would say yes.
Okay, so let's do a poll. Okay, we have votes. Yes, we have 17 votes. Perfect. Okay, so let's talk. For those who said yes, these are different, you are correct.
You said it what? I'm sorry, Dr. Henry?
Those who said yes, these are different, you are correct.
Dang.
Okay, so let's talk about how they're different.
Okay.
Where are the chlorine located here in this first one? Number 1.
First carbon.
It's on the first carbon, right here, 1. Where is it located here?
Is it the second?
Nope, still on the first carbon.
First carbon.
Where's the bromine located?
Second carbon.
Second carbon.
Oh, sorry, second.
Color. And here?
Second.
Okay. And then on the third carbon, I mean the third one, where is it located? Where's the bromine located?
Second.
Second. Where's the chlorine located?
Second.
So do they have different names?
Yes.
Yeah.
Okay. So these guys are going to be the same because your carbons, because it's a single bond, they're going to be flexible. So they can actually rotate and move, right? And since these are just hydrogens, both of these are hydrogens, they can actually rotate in the same direction so that these guys will be exactly the same thing. So 1 and 2 are going to be equal to each other. They're going to be the same. But 3, number 3, here, this guy's different because first off, it has a different name. How will we name number 3? Now, don't everybody yell at me at once. Gosh, you guys just talk so damn much. I just can't get you to shut up. Come on, help me out here.
Propane.
So it has 3 carbons, so it's propane.
Nothing.
So what do we have located on our propanes? And where are they located?
Would it be
Two methyl?
2 what?
Methyl?
Where are you getting methyl from? Is there a methyl group? Is Cl methyl?
No, my bad. Never mind.
So what is Cl? Tell me the chemical formula. The chemical symbol. What is it?
Chlorine.
Chlorine. So we would say chloro.
Chloro. Okay. So 2 chloro.
2 chloro. And then what's also located there?
1 bromo.
Is it for this one, for number 3?
2 bromo?
Yeah.
2 bromo. 1, 2. It's also located on the second carbon. We got to say the location, right? So it'll be 2 bromo. So it's 2 bromo, 2 chloro, propane. So that tells me that I have a chloro and a bromo on the second carbon of my propane. So what is this guy's name? These guys here.
They are
Propane.
Propane is going to be my base. That's good. Propane. Okay.
2.
Then
1
chloro.
And then 2
2
bromo.
bromo.
there we go. So it'll be 2 bromo.
And 1 chloro, right?
And 1 chloro.
Why would you write Why would you write the bromo first? This might be dumb.
No, it's not dumb. That's actually a good question, right? So it's priority. So in terms of priority, fluorine, since fluorine is the biggest bully ever, he has priority in terms of the halogen. So fluorine would always be go towards the back. Then it would be chlorine. Then it would be bromine. Then it would be iodine. Because if you look on your periodic table, you guys have your periodic table available?
Yeah.
Right? So if you look at the order, you have fluorine is up top.
Yeah.
It has the most priority. It's big bonds. Then it's chlorine, then it's bromine, then it's iodine. So when you have to compare those guys, fluorine gets priority. So that means it goes towards the back. So think about it. Okay, so we're in a patriarchal society, right? So we take the man's last name. So since I'm a man, my wife is going to get my last name, right? So I go to the end because I'm the most important. I'm more important than my wife, right? Isn't that what a patriarchal, can't even say it,
Patriotical?
Thank you. Patriarchal society. Isn't that the basis of a patriarchal society? I'm struggling.
It's good. Yeah. Yes, it is.
Okay. So it's the same thing. The guy who's the most important gets their name at the end. Okay. So if you got married 16 times and you want to keep all your names, the one who you're married to, that you're still married to, is the one that gets the name at the end.
Okay.
Okay.
No, don't do that.
Okay. So, questions, concerns, Cash?
Okay.
Venmo?
So the Venmo, the bonds. Okay, so if there was a double bond in there somewhere, that would also change it too, right?
Yes. Yes, it does.
That's what I
Because
was
the
paying
double
attention
bond,
to. I was like, oh, all the bonds are the same, so we're okay. But
in the case of a single bond, but if there's a double bond, it definitely changes it, right? Because then you start talking about whether things are across from each other or they're next to each other. So if they're across from each other, right, it's trans. So like if you think about a person who's changing their sex, you're going from a male to a female. They're called transsexuals, right?
Right.
Right? Okay. So that's the same thing. So if you're across from each other, that's trans. If you're next to each other, that's cis, right? So if I don't have a good analogy for that. Cis. Trying to think of a good analogy. Cis. But that means that you're the gender you were born with. In what? Okay. Cis. Okay. So yeah, that's, to me, I'm like, that makes no sense to me, right? Because you're just saying you're the gender that you were born with. So, okay. Okay. So I'm learning something new every day. So you can be cisgendered, right? That means you're born with the same gender that you were born with. I mean, you're the gender that you were born with, cis. So trans is when you're changing or you've changed. And then cis. So if you're on the same side, let's say we had, in the case of a double bond, let's do this. Let me give you an example of it.
Sure.
Yeah, please.
Somebody's going to catch and they're going to expect me to give you an example of transgender and cisgender. Oops. And you can thank Jessica B for this.
Sorry.
That's all right. You're going to get it anyway, so it didn't matter. But I want to blame somebody. I always blame myself. Okay, so here, the bromine's being across from the chlorine, that's trans, because double bonds can't rotate, right? They're kind of stuck in position. Okay, that's called trans. So we would name this, we'd say trans, and then give it its name.
Okay.
So then that means that tells us that the double bond can't rotate and you have your bromine and your chlorine away from each other. Okay, so cis means that they would be both on the same side. So this would be an example of cis. I'm gonna make it smaller so we can actually fit it in there. So
What was that name for that one, Dr. Henry?
trans, like a transgender.
So would you say, just out of rule of thumb, that if you see a double bond like that, like the same structure, you can automatically say that it's trans?
If they're across, if your two attachments are across from each other, is trans. Yes,
Okay.
but this guy is cis. So do you see the difference between trans and cis?
Yeah, the cis, like you just said, for the trans, they're not across from each other.
That's right. So cis is all both on the same side. Trans is when they're opposite of each other. They're across from each other. You see?
In regards to the bromine and the chlorine?
That's right.
Okay.
Regards to the bromine or the chlorine. Regards to your functional groups, right?
Got
So
it.
hydrogens are not considered functional groups. Functional groups are things that are going to be different than hydrogens, right?
Got it. Okay.
Okay.
Thank you.
Questions? And so in terms of rigidity, right? Double bonds are rigid, so you can't rotate. Single bonds, you can rotate, okay? Triple bonds are rigid. You can't rotate. They're not moving, okay? How are you guys doing so far? Brain's not too fried yet? So that's all right. I like it super fried. Okay. Let's see. Okay, so we've been talking about these hydrocarbons and everything like that. And you guys are like, man, you know, these are so hard and everything like that. They're a piece of cake. We're going to make it a little bit harder, right? Because you're starting to get it now, right? So we got to add another layer of complexity to it. So, okay, so we divide our hydrocarbons up into two groups. One is basically those chains that we were talking about, those nice little chains and everything like that. And the other things are, and that's called aliphatic, right? Aliphatic hydrocarbons. So that means they're basically chains. You can have branches and all those beautiful things. And we have what we call aromatic. Aromatic. Have you heard that term before? You hear them on commercials every day. Aromatic. Have you ever heard that term? Anyone?
Yes.
Like
Yeah.
Febreze?
Febreze, yes, Febreze. Aromatic, right? It means it smells, right? So we have hydrocarbons that smells. So aromatic hydrocarbons are basically hydrocarbons that form rings, and that causes a lot of the smells that we have. So do you guys like strawberries? I love strawberries.
Yeah.
I do, right? I do. I told you, strawberry cake, that is the cake. If you watch the video in the syllabus, it ends with strawberry cake. It's my favorite cake, right? Love the way strawberry smells. Fresh strawberries. Nothing like
The strawberry farm?
I love the strawberry farm. I drive by it every day when I come back from Fireball, right?
What?
I'm like,
Oh, 5.
or what is it? Boom Farms, strawberry wine. Oh,
Come down to
best.
the 805. We have a strawberry festival every year.
Oh, really?
Uh-huh.
Okay, so I know where to come. Yeah, definitely gonna hit that up. What time? When is it usually? Although they may not have it now.
Around, like, it was like 2 months ago, but because of the pandemic, it was
Canceled?
shut down. But it'll
Darn it.
probably be up next year.
Okay, I've got to put it on my calendar. I'm gonna hit that strawberry, yes, festival. Love it.
Yep.
Strawberries have a very unique fragrance, right? Isn't that part of the reason why they call it fresca in Spanish?
For fresas?
Because, is it, what was it for fresh? Say it again.
Fresa. Fresca means fresh.
Fresh, fresh. But you call it fresh because of the smell, right? It don't smell. If it smelled funky, you wouldn't call it fresh, would you? Yeah, you would call it fresh?
No. Ew, no.
Okay. I'm just asking, you know, it's like you guys are not answering me, so I'm just making assumptions about you. I'm like, dang, they dirty people. So the key is aromatics, they form ring structures, right? So now we're getting into some complexities, right? So one of the major rings is called the benzene ring. Okay, it's not pretty. Benzene ring has 3 double bonds. They're alternating between carbons. So that's a benzene ring.
What time?
Okay. Each one of these are carbons. I know it's not pretty.
1 and 0 together. 10. And then what's a 5 and a 7 together?
And I know somebody's going to ask me. So where do you start counting from? Somebody's going to ask me that?
Yeah.
No, you can start from anywhere. You can start from here. 1, 2, 3, 4, 5, 6. So we can start anywhere on there. 6. Okay? Because there's nothing attached to that benzene ring.
Stay on this road, do you understand?
Okay? So as soon as we start attaching things to that ring structure, let's say we put a chloro group on our ring structure. Oops. Okay, I know my structures are not the prettiest. This is why I'm not an art major. Say we're going to put a fluorine here. So we're going to put a halogen. So as soon as I put a functional group there, then that becomes that first carbon. So then this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay? Piece of cake?
Yes.
Okay. So if they're all, instead of a double bond, alternating, so again, this guy's called benzene, right? They consider it a special name. If they were all single bonds here, it has 6 carbons. What would we call it?
Hexane.
Hexane. So we would call this guy, since it's a circle, we would call it cyclohexane.
What?
I'll write it out. I know it's a pentagon, but we call it a circle since it's connected.
Okay.
So we would call it cyclohexane. If it was 4 carbons,
What do we call it? A butyl? Butyl? I don't know how to say it.
okay, 4 carbons, what would we call that guy?
Wait a minute.
Butane.
Okay. But what would we put in front of it?
Cyclo?
Where?
Where?
Cyclo butane.
Oh.
It's
Like
9 carbons
connected. Right?
in
Cyclo?
a circle. What was that?
Cyclo is because it's connected.
That's right, because it's connected.
Okay.
Would there be 3?
So 3, it does exist, but is not stable. So if there was 3, it would form a triangle. We would call that guy what?
Right.
A cycle. I don't know.
Cyclo, did you say cyclopropane?
Yes.
Because 3, right?
Yeah. Oh, yeah. Cycle.
Yeah, so this guy isn't that stable because the angle that it has to keep. Actually, cyclobutane is a little more stable, but it still isn't stable. When we get to cyclo, what about this guy? What is this guy called? Don't say my house.
Pentane?
Cyclopentane.
So the more it has, the more stable it is.
Yeah, so the more carbons it has, the more stable it becomes.
Okay.
Yeah. Okay. So this guy is not stable, so it doesn't last too long. This guy is less stable, but it's more stable than this guy. And then cyclopentane is stable. After you get to cyclopentane, then everything becomes stable. Okay, and that's because of those. Remember we were talking about Vesper? What does Vesper mean?
Valence electron.
So valence electrons, that's right. So Vesper. Valence electron.
Is that where you do the configuration? You figure out their sublevels?
Nope. That's electron configuration. Vesper. It's in chapter 13. What does the R stands for? That's the most important part. Electron, shell, pair. What? What does the R stand for? Repulsion. What does that mean? What are we talking about?
They repel.
They repel. When do they repel?
When they're close to each other?
If they're close to each other, right? So the goal is, do you want to put 2 electron pairs close to each other?
No.
You want to try to get them as far away as possible, right?
Yeah.
Okay. And so if you guys take a look, you can have cases where you have 90 degrees. So that would be like here, 90 degrees. So that's why this guy's a little more stable than this guy. This guy is less than 90. We're getting electrons really close to each other, and they're not going to like that so much. And that's why they lack stability. These guys, we get beyond 90 degrees, so they're happy. In this case, and in this case, they're beyond 90 degrees. Yeah, see that?
Yes.
Okay. So it's important to understand how Vesper plays a part in the structure, and it also affects stability. Now you see how everything is starting to play on each other? We're just building and building and building and building.
Yes.
Yes. Okay. Okay. Whew. I'm getting hot thinking about this. Just turns me on so much. Okay. So we've also talked about saturated and unsaturated. You're familiar with that?
Mm-hmm.
No? Who said no?
No, I said uh-huh.
Uh-huh. Okay. Saturated means what?
Single bond.
Single bonds, all single bonds. Unsaturated. Like your fat.
Several bonds.
There's more than single bonds. You have double bonds or you have triple bonds, or a combination of both, right?
Yeah.
Okay. So that beautiful table, did you say you want this? Do you guys want this?
Yeah.
I'll put in resources.
Please.
Okay. So I'll add that. Israel, you got that? You're gonna add this to resources for me? This table. Okay, now the thing that you're gonna want to also know, and we're gonna talk about it in more detail later on, but right now, if you notice, all of these guys here, your meth, your eth, your prop, your bute, all of those are gases. Now these guys become liquids. Why do you think they become liquids?
Because they're more stable.
They're more stable, okay. Well, that's if they're cyclo. These guys are stable. These guys, methane is stable. Have you been around cows? Does their fart dissipate real quick?
What? What did you say?
I said, do cows fart dissipate? Mean disappear, right? Does it dissipate real quick?
No, it lingers.
It lingers, right? So it's stable, right? Unfortunately, it's too stable, right? So these guys are stable. When they're not stable is when you're trying to form those ring structures, right? So here, these guys are stable, but the reason why that they're gases is because the way that they interact with each other. They're non-polar, right? But if you have stuff that's really big, these guys, your carbons are getting bigger, right? At 5, you're starting to get pretty big. So what we have are two non-polar things that are interacting with each other. They interact with other forces, right? Basically, they're capable of forming hydrophobic interactions, right? So you have two hydrophobic things that are going to interact. They're alike, they're long, they can't go up in the air real easily, right? And these guys, the bigger it gets, the harder it is to boil, or its boiling point increases because of those forces. You have more of those, what we call, what are those forces called? Vander Waals forces? There's another name for it? Well, it's intermolecular forces in general, but these forces are called what? You guys remember? Anyway, you'll learn about it later. I'm going to hold them to it here in a second because they should remember it. But right now, all you need to know is that as your carbon chain increases, it's going to become more of a liquid, right? So methane, ethane, propane, and butane are all gases. Pentane becomes a liquid. Now, pentane, you can boil at a very low temperature. Hexane, also a low temperature. But as we increase, the temperature of boiling gets higher. Your gasoline, does your gasoline just boil up? Does it boil up easily?
No.
No? Octane. Octane is gasoline, right? You've heard of octane. It's so much octane, 77% octane, right? Yeah. Have you guys heard of octane? You haven't. Watch a gas commercial. You've heard of it. You're just saying that you haven't just to be difficult. Okay? So your octane, look on your, when you go fill up gas, you guys fill up your, how many people have cars? Everybody have cars?
I'm here.
Yeah?
Yeah.
Okay? So when you go fill up next time, look, it says something about octane. That's gasoline. So we know that gasoline's a liquid, is it not?
Yeah.
So if you get a question, why is gasoline a liquid and ethane is a gas? What are you going to tell me?
Ethane has a, sorry, go ahead.
No, go ahead.
Oh, I was just going to guess, like ethane has a shorter carbon chain?
That's right. Ethane has a shorter carbon chain, so there's less interactions that are going to be happening. So the fact that you have a longer thing is going to have the ability to have more interactions with those hydrophobic means, because they're both hydrophobic, they're both non-polar, right? but you only have 2 carbons to work with, where in the case of octane, you have 8 carbons to work with for interactions. Okay? So this tells you those instructions, that IUPAC nomenclature, pick out the longest chain. It tells you about the whole branching part of things. It tells you about that bromo component. Remember, the cycloalkanes. So those are just circular rings. Okay? You know about the unsaturated. We've already talked about it. How you feeling so far? Aren't you feeling brilliant? You should be feeling real smart. You know this stuff already. Okay. Let's see. Where do I want to get to? Okay, alcohols. Do you guys like alcohol? Who turns up?
I think we all do, but we secretly don't want to say anything.
Uh-huh.
Oh my God.
I know chemistry have you guys all turning up, right? I saw it in some of your faces the other night. You look like you're hungover after that exam. I'm just saying, right? And then some of you guys look like you're hungover based on test scores before you finish the exam. So you started a little early. That might be the problem there. Okay, so alcohols is our next order in terms of priority. So let's talk about our priority list so far. You have this list that's running. Our lowest, who's the lowest guy on our priority list? You guys, anybody remember?
Are they the halogens?
Halogens are low, that's right. So we have, so alcohols are higher than our alkynes, which are higher than our alkenes, which are higher than our alkanes. And then we have our halogens. Okay, so that's our priority order from top to bottom. These guys are the most important, these are least. Okay, so alcohols basically have an OH group attached to them. Okay, so for instance, what would I call this guy? And I'm not going to put the, when you're doing the nomenclature, you don't have to put the the 2 pairs. It's understood that it has 2 pairs, okay? So you know that really, if you have to draw the Lewis dot structure, we draw like this. But for our purposes, we don't put the pairs there, okay? When we do just nomenclature, that's why we draw it like that. R here, R stands for your functional group, or it stands for your hydrocarbon chain, okay? So if I'm drawing it like this, what would be the name of this guy? Or what would be, how many carbons is this oxygen attached to?
Yeah.
Oh, by the way, you put, what was that?
What do you want?
It has 1 carbon. So what would be the root for 1 carbon? What would be the prefix for 1 carbon, I mean?
Met.
Meth, that's right. Like a meth head, right?
Yeah.
Meth. So we would call this guy, since it has 1 carbon, we would call it methanol. So we add OL at the end. If it was just the carbon by itself, it would be called methane, and it's called methanol. You guys get that? So if I have 2 carbons.
Go, Sissy, go on. You can go.
What am I going to call that?
Ethanol?
Say it again, please. A little louder.
Ethanol?
Ethanol. So ethanol is drinking alcohol. This is what you turn up with. Okay? If it has methanol, is called wood alcohol. You don't want to drink that. That makes you go blind and you get hairy palms. Oh, that's something else. Wait a minute. No, but methanol does actually cause you to go blind. Okay, so if I have 3 carbons, what am I going to call that guy?
Propanol?
What was it?
Is it propanol?
Propanol. Holy crap, propanol. Have you heard of propanol before? Isopropanol, propyl alcohol, propanol.
Yeah.
Okay. What about if it has 4 carbons?
Maybe
Butanol?
butanol?
Butanol. Okay. Questions, concerns, Cash?
Could you explain the R to me again?
Can you repeat that, please?
Could you explain the R to me?
Okay, I can hardly hear you and you're breaking up. You're talking robot.
The R. It says the one that you circled.
Can you type it in the chat box? Oh, can I explain the R group again? Yes. So when I talk about the R group, the R means it could be any hydrocarbon, right? So we could have it, so it's just 1 carbon. It could be 2 carbons, so then that's ethyl. It could be 3 carbons. So this is just, when we talk about that R group is just being attached to our functional group. The OH is our functional group. The R group is just the hydrocarbon that's going to be attached. So we could have any chain of carbon and it makes it an alcohol. Okay? So if the OH is attached to an end, right, like it is here, these guys are called primary alcohols, right? Because they're attached at an end. So primary alcohols. If they're attached to an inner structure, and I'll show you an example. Let's see. Do you mind if I go to a whiteboard? It may be easier to see.
Sure.
So if I have this guy, so this is called a secondary. Okay. So secondary, because it's attached to an inner structure. And we can also have what we call a tertiary when it's attached to a side chain. Okay. So primary, And we call it just general because it's attached. But that isn't the name. If they ask you, it's like a family, okay? So this is a primary alcohol. This one here is a secondary. And then a tertiary. A tertiary is when it's attached to the side chain. I have to look how to spell it out right. Oops. Okay. So questions, concerns, Cash?
So Dr. Henry,
Yep.
when you see so whenever we see the OH like in a chain, is it most likely gonna always be an alcohol?
Yes, so it falls under the alcohol family. Now, depending on who it's with, right? It's based upon priority. We're gonna talk more and more about priority. So the next one in line is the alcohol, right? The one that's gonna be above that one. So the ether is gonna be above that one. So it has a priority over the alcohol. So then in the case of it, if you have an ether and you have an alcohol, the ether has priority. The ether gets the last name, okay? So the way that we handle it, and we would say hydroxyl, right? Or if there's an alcohol and an ether, so we would say hydroxyl, and we'll tell where that hydroxyl group is at. Do you understand?
Yes. Yeah.
Okay. And so we're working there, right? I'm giving you the names, and we're building that up, that hierarchy, right? So do you guys understand the concept of the hierarchy?
Yes.
Yes.
Okay. So the major parts that I want you guys to get out of this and what you're going to be tested on, from my perspective, is going to be the hierarchy and understanding the base of the names, right? You need to be able to do at least the basic names. When we get some of these other structures, it's going to get a little more complicated, right? But I just want you to get the base of the names, okay? And you should be able to identify the different functional groups. You should know what an alcohol looks like. So what does an alcohol look like?
OH.
There's an OH attached to it.
It has to have an OH attached to it. That's right. So what does a halogenated hydrocarbon look like?
Carbon chain with a
halogen attached.
A carbon chain with a halogen attached. Okay, simple so far, right? What does an alkene look like?
A double bond.
A double bond.
What does an alkane look like?
Single bond.
Single bond. Good job. Okay, you guys get that?
Can you show me the halogen one? Because I'm a little confused by that one. You said it's how does it, it's like, it's a bond attached to what? Sorry.
It's a hydrocarbon attached to a halogen.
Oh, okay. Now, okay, now. I get it now.
Okay, so these are all alcohols. So this is a secondary alcohol, this is a primary alcohol, and this is a tertiary alcohol. Okay, yes, San Juana says, so like a placeholder. Yes, R is just a placeholder. Okay, and so you could put any hydrocarbon in there. Okay.
So in this case, the bromine's the hydrocarbon on this bottom one.
So no, the bromine is not the hydrocarbon. The hydrocarbon is the hydrocarbon, right? Because what is this? What does this all consist of? This here. So we would write this, the way that we write brominated hydrocarbons, we would just write that as R dash, and we put halogens. So typically people put H for halogens. So we'd write RH, or you could just write, if you want to be specific, brominated hydrocarbons would be BR capital R, where R represents any hydrocarbon. You guys get that? So the way we write alcohols is R, very generally, ROH. Aren't all of these guys, isn't this a hydrocarbon here? That right there? I should write that in a different color.
Dr. Henry, what does R stands for?
R means any hydrocarbon.
Right.
You guys get that? It's kind of like, you know how we use N for variables, right? Or you use an X, where X could be any number when you guys were working with math?
Yeah.
Right.
It's the same thing. Only thing R means hydrocarbon. Okay? So do you understand what an alcohol looks like? So if it has the highest priority, we always end in the word with OL. Okay? If it has the highest priority. If it isn't the highest priority, then we call it hydroxyl. So hydroxyl group. Okay, so if there's something that has a higher priority than it does, then we have hydroxyl. Okay, so I'm going to ask you this. Based upon what I told you earlier, how would I name this guy? This was a double bond here.
That's where I'm confused. Would you
it be?
Would you start with the OH because it has the highest priority now over the double bond?
That's right.
Okay.
So then it would be how many carbons?
4.
3.
Okay.
Three.
So we have 1, 2, 3, because this guy's attached to that OH. Okay.
Yep.
So it's 3. So what would we call it? If it's 3, if it was just a single bond, what would we call it? 3 carbons?
Propane.
Propane.
Or propene.
Propene.
Okay, so it would be, since it's a double bond, we would call it propene-all.
Yes, and then we'd have to put the 1.
That's right, and we'd have to put the 1 in front. That is correct, because it's located at the 1. Although, wait, hold on. That isn't true in this case, though. We're kind of screwed, because who has priority?
The alcohol.
Alcohol.
The alcohol has priority, so then this would be the first carbon, this would be the second carbon, and this would be the third carbon.
Okay. So
So
it
it's
would
alcohol and then the double bond, right?
What was that?
I'm confused. I don't know. So
you have to
alcohol
put
and then
3 instead of 1.
Over,
Oh, sorry. So then it would be 2, right? Now, what were you saying, Tiffany? I'm sure that was Tiffany, right?
yes, just, yeah, continue on. I'm just speaking out loud.
No, but I want you to speak out loud because what you're saying has relevance to some of the other students. They're going to have the same question.
No, go.
By you asking it, it helps us get it cleared up.
No, go. I know alcohol's first, and then would you write the double bond in there next?
Yep, and that's what we did, right? We put the E in instead of the A in.
Gotcha.
Mhm.
right? So if it was just that single bond, I'm going to erase this guy up here, and then we'll talk about this guy. So if it was just this guy is called what?
Propanol.
So it'd be called propanol. But if we want it to be exact, what do we need to do?
No, no, you're bothering me. Oh.
Whoops. Propanol. Where's the OH located at?
It'll be the first one.
Okay. So here we also should probably be exact. Right. So we were talking about the ene, right? So let me show you what. Make this correction. Oops. So you will see it in cases like this. You'll also saw it the way that I wrote it, where we were talking about the two, the ene. So then it's understood that the all is the number one. That's understood, but it has to be exact so that people don't have any questions. So the top one would be your preferred choice. Okay. So then you're telling everybody, okay, I'm letting you know for sure that the alcohol is located on the first carbon and the double bond starts on the second. You guys see that?
Yeah.
Yep.
So although if you look online, you'll see it written a couple of ways. Okay. But you want to try to be as exact as possible. And that's what IUPAC is about, is trying to be as exact as possible. So we know where everything is at. So there's no assumptions, because otherwise we're making assumptions. And a lot of times when we make assumptions and they're wrong, that causes explosions. Okay. Questions, concerns, Cash? So these are alcohols. I have one more thing to talk about, and then I'm going to let you guys go. I want you to next start drawing your next set of structures, right? And we'll add this point as extra credit towards your homework. So, because I can't keep giving you guys extra credit points towards your test grades. Okay, so let's see, let's switch screens. How are you guys feeling so far? I know you're going to say overwhelmed, but that's okay. You're going to get it. It's going to start clicking. Okay, so your ethyl group, right? Your ethyl group is basically ether. I mean, it's a hydrocarbon and another hydrocarbon separated by the oxygen. So for instance, so here they basically have already drawn it for us, right? So this would be methyl dimethyl ether, right? Oops, I was going to spell it the way that Andy likes spelling it. So why do you think it's called dimethyl ether?
Dimethyl.
Have one carbon.
So this guy. Why? Because there's one carbon over here. There's one carbon over here, right? So there's two methyl groups attached to that O. So that's why we call it dimethyl ether. So what do you think I would call this guy?
One
Would it be
with O, it's nothing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
so would it be 1-methyl?
Methyl.
So it would be methyl.
Right.
It wouldn't have to be 1-methyl.
Okay.
Methyl. What's on the other side?
3. You have 3 carbons.
1, 2, 3,
Propyl?
4.
Propyl.
Yeah, remember propyl.
And then you put ether at the end. Not either. Okay? So it's methyl propyl ether.
Oh my God.
Simple?
No.
No. What's hard about it? What's on this side? One side? What's on the other side? Because you only have 2 sides.
Yeah.
Okay, so you want to try one more?
Yes.
Andy, I guess it's just me, you, and who's ever speaking really low. I think that's Deandra, but I'm not 100% sure. Okay, let's try this one.
I met letter. What? That's a lot.
So would it be butane?
1, 2, 3.
So it would be butyl. Is that what you said?
Butyl. Yes.
Butyl.
Heptyl ether?
And then heptyl ether.
Heptyl. That's right.
And then
Protein.
Oops.
Heptyl.
Okay, simple.
Heptyl ether.
So we're not counting the point closest to the O, right?
Yeah, because that's attached to the O.
Just making sure. I'm
Yep.
counting.
So you count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4.
Oh my God, that is so simple, and I just came on.
Now it's gonna be harder.
Okay.
Like that.
Piece of cake?
Candy, this one is okay. Candy.
Okay.
Okay, I gotta go again. I'll see you guys at tutoring.
So if I have this guy,
What is it? One,
what is that called?
1, 2, 3, 4, 5. Rectangle.
so that's
Pentyl. No? Would it be
This is a,
pentanol?
I'm sorry, this is a separate molecule. I'm not putting it on there. So what is it called?
Would it be 1 pentanol?
1, 2, 3, 4, 5. So pentanol. Or 1
Or would
pentanol.
you go backwards?
What was that? Or sorry, yeah, 1, 2, 3, 4, 5. So it would be 1 pentanol.
Yeah.
Okay?
Yes.
Simple?
Yes. Easy.
Okay. What about this guy?
so it would be 6. So it'd be methyl.
See, because it's not connected to that, would that be 6 or would that be 7? 3, 4.
That's 1, 2, 3, 4, 5, 6, 7.
Hepta.
So heptyl and
And then you have one
Methyl.
carbon on the OH.
So where's the OH located at?
3.
It's methyl.
At the
Fourth. So
So that's 1, 2, 3, 4, or 1, 2, 3, 4. So it's the same either way.
Right.
Okay, so it'll be 4
Methyl.
for
Methyl.
heptanol.
Methyl. No.
not yet, Lily.
Okay, you guys ready for a hard one?
I need to get my day now, guys. Oh, yeah.
See if I could get a really hard one for you. Make you think a little bit.
So, man.
Okay. First thing I want to do,
Well, your highest priority would be the alcohol,
Right.
right?
okay, so this is my highest priority.
Yes. So that means
Okay.
you would read it from right to left.
You said right to left. Okay, so start here.
Yes.
Yes.
That's 1,
That's 1.
that's
two.
2, that's
Okay.
3, that's 4, that's 5,
5.
that's
Six.
6, that's 7, that's 8, that's 9. Okay, so what other functional groups do we have?
And then you have the,
Very nice.
would it be the ones that fall under 5?
Okay, so we have this guy. So what is
Yes.
that guy called?
Propyl?
Is that your,
1, 2, 3. So it's propyl.
right?
Okay. And
4 is methyl.
Okay.
So we have
So
3,
Methyl.
3,
trimethyl.
6, and
so we have a
7 are
methyl.
Methyl. 1, 2,
Okay, so we
3.
have a methyl at 4
And
And
then
at
a
4.
methyl
Four.
at 3.
and a methyl
at
where? And at 7?
3 and at 7.
No, this is that's the OH.
Oh yeah, you're right, you're right.
Cat doctor by methyl.
Now let me make this. We'll make it red. So here, that's an OH. Okay.
Okay.
So we're not making a mistake on that. Okay, so did I change the color? I ended up having the same color for this guy. Let me fix this. Okay, so are we ready to name it? What are we going to call this guy?
Nani.
So would it be 6,7 methanol?
9.
I heard something 7-methyl.
Would you do 4?
Would it be 6,7 or 4,7?
Yeah.
Methyl.
Okay. How many methyls is that?
Die.
2.
Di.
2.
Methyl. Dimethyl.
Right.
5 propyl.
5 propyl.
Propyl.
And
The longest chain is 9.
3.
And then would you write the 3-OL or
No, you write the name. What's the major carbon chain? 3 what?
9?
Nano. Nanol. There you go.
Oh yeah, sure. Adding the OL to that. Okay.
That's right.
Got it.
so where's the 3 come from?
Because where is the OH at, Andy? What carbon is it on?
Oh,
It's on the 3rd carbon. 1, 2, 3. So we're saying that that OL is on the 3rd carbon. So the OH is on the 3rd carbon.
HO is a carbon?
No, OH is on the 3rd carbon. It comes off the 3rd carbon. It's a functional group off the 3rd carbon. So OH, we put OL for alcohols. All alcohols they have an OH in them.
Dr. O'Hara, sorry, what's the 5-propane again?
5-propane, 5 on the 5 carbon. That's 1, 2, 3. So that's 3 carbons.
Okay.
What do we call 3 carbons?
Propane.
No, we call it propyl because there's 3 carbons on the side chain. Right?
Oh, okay.
So anytime that it's on the side chain, it becomes YL.
Okay.
Okay?
Because we're dealing with alcohol, right?
Yes, alcohol has priority.
Okay.
Right? So then we go, that means that it has its last name. It's the last part of the name, right? So that's why we put the OL here. It has priority. Then we find the longest chain, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why we call it nonanol. And then we have to tell where our alcohol is at, right? Because it's not a primary alcohol. So we have to say 3-nonanol, right?
Okay.
Then on the 5th carbon, there is a side propanol, 1, 2, 3. So we call it propyl.
All right.
Right? And then we have 2 methanes, right? So we have, or 2-methyl. So we have 4,7-dimethyl, since there's 2 of them.
Okay.
Dr. Henry, I have a question.
Yeah.
So like say if there was a double bond and will we still start with a double bond or is only with alcohol no matter what?
It's the alcohol because alcohol has higher priority than a double bond.
Okay. I just want to
No, that's good. It's a good question, right? Okay. That's the same thing like with the triple bond, right? So alcohol is higher than a triple bond. So alcohol has priority. So if there's a triple bond there, then still the alcohol has priority over it.
Okay, thank you.
Okay. So how you guys feeling?
Not too bad, but definitely need some practice.
Yeah. And the best way to practice is to draw them out yourself and see if you can name them.
Okay.
Okay.
Thanks for doing all those examples, Dr. Henry.
Yeah, no problem. That's what it's about. I know we're going a little slower than expected because we need to get to the classic inorganic nomenclature. So that's going to be fun. But if you understand this, right, if you're getting a grasp on this, inorganic nomenclature is going to be like a piece of cake. Strawberry cake. Okay? Questions? Concerns? Okay, I'll see you guys tomorrow. If anybody's cake come in, please let me know. because then I can start harassing you about doing your experiments.
So I have a question about the homework assignment that you were talking about. So we're supposed to make our own and upload them, or were we supposed to also answer the other questions that you gave us?
You're supposed to do both, but I wanted you, for your extra credit, I want you to send me your questions, because I already know what my questions look like, right? So,
Yeah.
but now that you've had a little more time and we've discussed things, I want you to go back to those questions, make sure that they're right.
Okay.
Okay?
Thank you.
And you guys should be meeting up with each other and arguing about stuff. No, you're wrong. This is what he said, right?
We just listened to Judy.
What was that?
As our study group, we listened to Judy.
I see that. So if Judy gets it wrong, that means you all get it wrong, right?
No, well, no, she's really good. That's what she knows what she's talking about.
Okay. See, I had another class like that. Actually, I had two classes like that. They jumped off the cliff with someone else. There's this one kid who is just like, he's a fucking genius, right? I'm not gonna lie, he's a genius, but he's a dumbass at the same time, right? So he's one of those students who he knows a lot of stuff. He's a natural at things, but he doesn't want to put in the time. And so he gets himself in these little circles where he makes these stupid ass mistakes. And so everybody was listening to him, right? He was the loudest voice. And he just kept saying, oh, no, we're going to do this, and this is what we should do, and this is what we should do. So I was going through, and this was the take-home test. I was going through and grading their take-home test. And I am like, what the fuck is this, right? It was just the most obscene thing. You would start cussing, you've seen it, right? And it was one of the most basic things that they should have known, like the back of their hands, right? But nope, they were insistent. They were just like, nope, we're going to listen to what he says because he said it. He's the smartest kid in the class. Dr. Henry loves him, right? So they all got a big fat 0 on that question. That question was worth 25% of their grade. So they already started off at 75, and then they kept listening to him about some of these other questions, and so they just tanked, right? Mm-hmm. And so the moral of the story is, again, you come to the table prepared. You don't just assume because that person is the smartest person in the class that they're going to always be right. Because sometimes the smartest person is on crack just as much as you guys are. So.
Yes.
Okay.
So you know how like we're going to correct our answers? Is this the only time we get to do that for just test 1? Didn't you?
Yeah, you have one opportunity. So if you don't want to waste it on this one, right? If you're worried that you're going to get worse. So, but the whole point of it is that the whole purpose is each time your score should be getting better because you're learning how to study. What I find is that most students, you guys have gone through college or you've gone through high school, you've gone through whatever form of schools, giving me bare minimum, not giving me bare minimum. I expect everything, right? But giving other instructors bare minimum. You got to understand, you want to give your all. You can't give me bare minimum and pass this class. You're going to have to give me more, right? And you learn that. You learn it. So you learn how to study. The fact that you guys get together and you start getting better. So that means that your scores get better. Mm-hmm. And that's usually the case for the average student. They always fail the first exam. And then they may get a D the next one in some cases. In some cases, they learn real quick and they end up going from an F to a B or an A, right? And then others, some people are just hard-headed, Yeah. And so you guys, you know who you are. You know yourself, right? Mm-hmm. So you're going to either learn from your mistakes or you're not, right?
I'm not going to lie. The first exam kind of killed my spirit a little bit.
Well, stop crying. You don't have enough time to cry, right?
I know.
So get over it, the whole purpose. Now you go through and you learn, right? You need to figure out what's going to work for you to learn.